What's up geeks, and welcome to the channel. The last video we added to this series of sorting algorithms was counting sort. This algorithm is great for sorting integers. However, when the difference between the minimum and the maximum value stored in the array we want to sort is very big, this algorithm might not turn out to be as efficient as it should. To solve this problem, Radix Sort was born. Radix Sort uses the same logic and the same implementation we discussed in the counting sort video, but with a few modifications. Therefore, if you haven't watched the counting sort video or have no idea what counting sort is, please make sure you do. To help you with that, I'll leave the link to the video in the description down below. Now, if you are still here, I will assume you remember that in counting sort, we were using the value of the integer stored inside the array as an index in the occurrences array. However, what we do in Radix Sort is use only one digit of this value as the index. This way, we can guarantee that the occurrences array will, at maximum, consist of 10 slots. Let's take this array as an example, and suppose that one of the integers stored inside it is 539. In counting sort, to count this value, we will have to create an array that can store at least 540 slots. However, in Radix Sort, what we do is use the 5, the 3, and the 9 separately to store and sort this value. And if we do that, all we will need is an occurrences array that can fit the numbers ranging from 0 to 9, which means an array of 10 slots at max. But how exactly are we going to sort an array by using only one of the digits of the values stored inside it? Well, let's fill this array with additional values and try to sort it using Radix Sort. After this example, I can guarantee that things will become way clearer. The first thing we have to do is choose whether we want to start sorting from the least or the most significant digit. In this example, we are going to start from the least significant digit, or the digit that is located at the very end of the integer. Therefore, we are doing what we call the LSD Radix Sort. If we choose to start from the most significant digit, we will be doing the MSD version of the Radix Sort. The MSD Radix Sort will be covered in an upcoming video, but for now let's focus on the LSD one. Let's go ahead and take out the least significant digits from each of these integers. These digits now form a brand new array that needs to be sorted. And to sort it, we are going to use the counting sort algorithm. The counting sort algorithm will generate the following occurrences array, which will allow us to easily sort the digits array. With this array sorted, we can now map these digits to their corresponding integers in the initial array, and with this, the first iteration done using the least significant digit is complete. The same process is then repeated on the following digit. The second digits are taken out and the integers are stored based on these digits again using the counting sort algorithm, which is only applied on the digits themselves. Finally, this behavior is repeated one last time on the last digit or the most significant digit. After doing that, the array of integers we started off with should be sorted, and this sorting was done using the Radix Sort algorithm. Now, before jumping to the implementation, I want to explain mathematically how we are retrieving separately each digit from a given integer. Let's take 539 as an example. If we calculate 539 modulo 10, we are going to get the least significant digit, or the 9. Now, the same technique is also used to retrieve the 5 and the 3. But there is no modulo operation we can do on the 539 that will return for us a 3. So, to do that, we are going to transform this 539 into an integer with 3 as its least significant digit. And then we are going to apply the modulo 10 on this integer and retrieve the digit 3. This is done by dividing 539 by 10 first. This will result in 53.9. And when converted to an integer, it will result in 53. Then 53 modulo 10 is 3. The same is done for the digit 5. 539 is divided by 100, because in this case what we want is the third digit from the right, and then 5 modulo 10 remains 5. Now that you know how each digit is being retrieved separately, we can go ahead and implement the Radix Sort algorithm. Concerning the class declaration and constructor, these are left exactly as they were for the counting sort algorithm. The next thing I did was take all the counting sort logic we previously implemented inside the sort method and moved it to another method. As is, I didn't touch it for now. I called this new method counting sort, as you can see. The first thing we need to change inside this method is remove the min and max functions call, as we don't care nor depend anymore on the difference between these two. This was the main goal of the Radix Sort in the first place, if you recall. And because we removed these calls, the occurrences array we are creating, or count array variable in our case, now only needs to fit 10 elements at max, which are the numbers from 0 to 9. And the loop that depended on the length of this array should now iterate until it reaches 10 only. The last thing we need to change is add the modulo formula we discussed a couple of minutes ago. This equation will allow us to retrieve a particular digit based on a given position. So, if we divided a certain number by 100 and then modulo it by 10, we will be retrieving the second digit of this number. This formula should replace the value minus min formula we had in the counting sort algorithm, as the digit we are fetching using this equation will be the index in the count array. Now, the implementation you see still has a problem. The position of the digit we are using in this formula, named exp, is not initialized anywhere in the sort method. And that's because it won't. It will be passed to it as an argument, as the counting sort method we just modified should execute for every digit we have in all the integers stored in our array. To do that, the method we just implemented should be wrapped with a for loop inside the sort method. In this for loop, we need to iterate over the digits of the integers stored inside the array the user wants to sort. But how are we going to make sure that this loop takes into consideration every single digit, even if it has different length among our numbers? Well, this loop will have to start at 1, and should keep multiplying this 1 by 10 until all the digits of the maximum integer stored inside the array are taken into account. This way, we will ensure that when the counting sort method in the first iteration is passed a 1, the integers stored inside the array will be moduloed by 10, hence retrieving the least significant digit. In the second iteration, the iterator will be multiplied by 10, hence dividing the integers in the array by 10 before applying modulo 10 on them. This will allow us to fetch the second digit from the right. With this, our Radix Sort algorithm is kinda complete. And before I tell you about a possible enhancement, let's go ahead and test this implementation as is. To do this, I created a main method, and inside this method I initialized an array holding integers, as you can see. I also printed out the initial state of this array, how these integers are placed inside the array before we perform any kind of sorting. After calling the Radix Sort method and printing the resulting array to the console, you can see that the array is now sorted in ascending order. Now, you may have noticed that this implementation only works with positive integers and cannot be used to sort negative values. So let's go ahead and fix that. One way to sort negative numbers using the Radix Sort algorithm is to partition or divide the given array into two groups, the negative values and the positive values. The negative values are then transformed to positive ones and are sorted using the normal Radix Sort algorithm. After the sorting is complete on both partitions, the values stored inside the negative array are negated again, and the sorted final array will consist of these negative values in reverse order, followed by the positive values as they were sorted by the Radix Sort algorithm. In code, the first thing I did was change the signature of the counting sort method. This method now takes an array of integers as an argument. This argument will of course be passed from the sort method, which is calling the counting sort logic. Therefore, the sort method should also be modified to take an array of integers as argument as well, and to return the sorted one. We also renamed the sort method to Radix Sort instead of just sort, as it will be used by the new sort method. The array is being passed as an argument now because the sorting will be done on two arrays, the negatives and the positives. Therefore, this logic will be reused twice on two different arrays. Now, inside the new sort method, we should start by dividing the initial array into two, the positive values and the negative values. This was done here using the streams.collect.partitioningby method. Notice the boxed method that was added also. This method will transform the stream of int we have, the primitive type, into a stream of integer, the wrapper type, which will allow us to execute the partitioning by logic that follows it, as such operations do not work on primitive types. This line of code will generate for us a map having true and false as keys. In our case, the value stored under the true key will give us the negative values, and the value stored under the false Boolean key will give us the positive values. Next, we need to call the Radix Sort algorithm on each of these arrays. However, the type stored inside the map is a list of integers, which is the wrapper class. But what our Radix Sort method expects is an array of int, the primitive type. Therefore, we had to map this list of integers to an array of int. This was done here using the streams.mapToInt method. Notice also that for the case of the negative array, we mapped the integers to their absolute value using the math.apps method. By doing that, we will be providing our radix sort method with positive values only in both cases. The next and last step we have to do is store the arrays returned by both radix sorts calls in one single array, which is the initial array. This is done by starting with the negative values and by iterating over this array in reverse order. Then, after copying all the negative integers, we start copying the positive ones from where we left off until the whole array is filled. Do not forget that while inserting the negative values, you will have to negate them again as they were previously mapped to their absolute value. Let's bring back our main method now, and this time call the sort method on an array consisting of a mix of negative and positive values. As you can see, the array was stored as expected. Note that if you provide this method with positive values only or negative values only and not a mix of the two, it will also work perfectly fine. So, that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.